So as I've been telling you for a couple days now, we're going to use Geometry Sketchpad, GSP, in order to look at how different shapes, when we put them on a coordinate plane and transform them and move them around, what happens specifically to the coordinates. So you guys are going to make your own shapes. I'm going to do an example of a triangle in just a moment. And then from your own shape, you're then going to identify what your coordinates are that you start with. You're going to put that in the table that's been provided for you. Then you're going to make multiple transformations. You're going to start by making some kind of translation going up or down. Then you may reflect it across either the X or Y axis. And at some point in time even rotate it, with the whole goal being that you want to identify what happens specifically to your original coordinates when you do these different types of transformation. We're going to use Geometry Sketchpad to do this, and then we're going to extend this into dilations later on, and then also not only dilations, but then also we're going to use it with similar figures, ideally at the beginning of the next month. The first thing you have to do is you have to go plot your points for what shapes you're going to have. So for me, I'm going to make a triangle. You go up here to where it says graph, you go down to plot points, and then you don't want to double click or to try and drop one of the dots onto the plot because it won't be able to transform quite as easily. Go to plot points to do that. So when you click on plot points, it's going to bring up this box right here. Make sure that it's clicked on rectangular. It should be, but just in case it's not, make sure it is. Then you're going to enter in your X value and your Y value in for here. Now don't click done. You want to make sure you hit plot. As you click on plot, it'll plot that point. Then it'll bring up another dialog box. For the second one, my X value was 6 and my Y value was 1. Then I clicked on the plot button again to plot my second point. Then my last point was the point 6, 4. Plotted that in. I then hit the plot button. After I did that, it asked for another one, but instead of clicking another one, I hit the done button because I didn't have anything else to put in. So when I hit done, then it was no longer asking me for points, but instead it showed me what my shapes or what my vertices were. So it gives me these 3 points, and as you can see, they're already highlighted as you look at them. But the thing that you need to make sure you do is we want to fill this in. So since we want to fill this in, you click them in order. This isn't a big issue because it's a triangle. But you're going to go around and click around the points that you have, whether it's 3, 5, whatever it is. As you click that, then you're going to hit Control P. As you do that, it'll then fill in your shape so that it's not just an empty polygon. It then fills in your shape with this kind of grid looking thing. All that we have here are the points 1, 1, the points 6, 1, and the point 6, 4. Now you don't have to do a triangle. You can do different shapes, but one of the things we're really wanting to look at, regardless of what it is the ordered pairs. You notice on the paper that you were given, it asks for the coordinates. So it's going to ask for the shape, it's going to talk about the transformation, we'll get to that here in just a minute, and it's going to ask for the coordinates. The coordinates are what you are going to be looking to see how they change. So you're going to have one original shape. You're going to start with, for example, my triangle, and I'm going to take these different ordered pairs, I'm going to put them in, and I'm going to see, this is the goal of what we're doing, to see how when I make different types of transformations, what is really happening to the shape, and more importantly, what's happening to the coordinates. Keeping up with the points is incredibly important. If you're having a little bit of trouble with that, or if you anticipate having trouble with that, one of the things I could suggest to you is to show the label. If you can track where it is, that's fine, but if not, you're going to right mouse click on the point itself, and then as you right mouse click on the point, then if you double click on the letter, you can rewrite the letter as it is. But just do that, click on show label for each point, and that'll allow you to do that. If you do decide to label your points before your transformation, it does give you this little prime thing. It looks like an apostrophe. So if you want to try and figure that out and do that, you can, but it's not an absolute necessity. So anytime I want to make a transformation, notice I've got this dashed box in here. I'm going to take my cursor, I'm going to highlight by clicking and dragging in order to highlight my entire shape. That's the first thing. With all my points and my entire shape highlighted, I go up here to where it says transform, and I'm going to make a transformation. Specifically, we're going to start off with a translation. As you click translate, it pops up with this dialog box, so to speak. You need to make sure that you have this box up, or this dot up here, click for rectangular. And then I highly recommend that you only do either vertical or horizontal, not both. I chose to go vertical, meaning I'm only going to move to the left or right. I chose to the left. If your computer is not set to where it's centimeters, then raise your hand so Ms. Dyson or myself or Mr. M, someone can come and help you out. After you click the distance, then of course you're going to hit the translate button and it's going to move your shape. Here's the translation of my triangle. It's been moved over to the left and we can now see what its coordinates are. Alright, so since this time I'm going to do a reflection, I need to first identify my line of symmetry. The way we do that, we're going to double click on the x-axis, since I'm going to rotate or reflect across the x-axis. And you can see these little lines start to come up. They kind of do a little double flash just to indicate that that's your line of symmetry. Then I also went and I clicked and dragged to get my entire shape. That way I could determine, that way I could tell the computer, tell GSP what it is I'm reflecting across this line that we've identified. You can see it'll be temporarily highlighted. Everything's selected, so I go back up to transform. This time though, I'm going to click on reflect. And it gives us this shape right here. Now the only thing I'll need to do is make sure that I recognize which point went to which point, so that way I can identify it for my table. Reflected across the x-axis. Now this last time I'm going to do a rotation. Now for rotations we have to identify the point of rotation. So I go to the origin and I'm going to double click. You can see how it's highlighted right there, and then you can see how it's kind of doing that flashing thing just like we had with the line of symmetry. I then need to go and I need to click and drag to highlight my entire shape, and then you can probably imagine what we're going to next. We click on transform at the top, and this time we're going to rotate, but this time we need to tell it specifically how far to rotate. So I'm going by a fixed angle. It already has the point about it, so I'm going to type in 180 degrees. You can do 90 or negative 90. You need to do a multiple of 90. That would be either 90, 180 or 270 degrees. Those are really your options because that's all that we're going to deal with. We can get into the rest of it another time, but as for today, those are the three angles, the three options that you should pick from by which you rotate your shape. This one's actually a little bit more complicated. You got to pay more attention to what your ordered pairs were. So as you identify your ordered pairs and where they started out as, you then got to see what happens to them and where they end up. Because you're trying to track what happens to the coordinates as you rotate. So the degree measure that you rotated by is really, really important because we're trying to find a pattern for what happens. So a 180 degree rotation versus a 90 degree rotation is obviously going to give us different results. So you got to make sure on your paper that you identify what it is. And my recommendation is whatever you choose, whether it's 180 or 90 or even 270, stick with that the whole time. On all of them, do the same. That way, whenever you are trying to find the pattern, it'll be easier to do. So to give a quick summation of what it is I want you to do, I want you to draw some type of shape by plotting points. Now you're going to pay very close attention to whenever you plot those points, what it is your coordinates are. You're going to fill in the table. You're going to look at what that is. Then you're going to make three types of transformations. Now the transformations that you make, you're going to keep the same every single time. So if you decide like I did that you're going to go -8 on your translation, then you need to make sure that you are doing a -8 translation the entire time. If you rotate 180 degrees, if you want to do that, that's fine. You just got to make sure that on all of them you do. So that way you can look to see what kind of pattern happens to your coordinates whenever you do a -8 translation. If you reflect reflect across the x. If you're going to reflect across the x, what happens every time? What happens every time when I rotate 180 degrees? You can pick, as I said just a minute ago, you can pick a different number. If you want to do 90 degrees instead, that's okay. If you want to translate up 6, that's fine. Just make sure whatever it is, you do it the same every time, and then you want to identify what's going on with those points. Try and finding patterns as to what happens. We'll discuss that a lot more in class on Wednesday.